Let's begin by meditating, bringing our attention to the eternal side of existence, feeling the heart, going beyond the inertia of the conditioned mind with its projections and remembrances. When you're ready, coming out of the meditation, Namaste, Ayush. Thank you for being here.
Thank you. Thank you so much.
Welcome.
Thank you so much for considering my request.
You're welcome. Yeah, it's lovely. Thank you for your resonance and synchronicity. That's why we're here together, and it's only the two of us, which at the beginning of things, that's sometimes how it works. So let me turn off this sharing. So yeah, why is it just the two of us and not many more people? I think it has a lot to do with the fact that this is something that people can't understand and place into a box, right? Spirituality and mathematics coming together is quite a novel thing. because of that, it has the potential to really make a change, but it also is a little bit more difficult for people to apprehend how it will fit into their lives. So what we're really doing here, mathematics usually is considered, okay, I need to develop proficiency to get good grades, to get a good career, perhaps to be an engineer or a business person. But we're approaching mathematics with the fundamentally different attitude, sentiment, which is that mathematics is a means by which we can better know ourselves, better know the universe, and awaken into greater consciousness and eventually become enlightened. This is a very novel way to look at mathematics, and yet Pythagoras was doing this 2,600 years ago. So it's not new, and it makes a lot of sense, but it is foreign to our modern day society, which is lacking in intellectual sincerity in a lot of ways, even though they're intellectuals. But the joy of learning for learning's sake is not as prevalent. And also, the relationship between spirituality and the mind, the intellect, is a little bit weak in society as of now. Usually spiritual people feel that intellectual rigor has little to do with spirituality, but this is very much not the case. Having a mind that is lucid, clear, well-structured is essential to be able to transcend beyond the mind into higher dimensions of consciousness. And if you study those who have done that, you will immediately recognize the refinement of their mind. Sri Aurobindo is one of the smartest people I've ever encountered. Rabindranath Tagore, brilliant poet.
Yes.
Paramahansa Yogananda is writing
Yes.
as a second language, or third or fourth, whatever, it's not his primary language. There you got it.
I'm reading this.
Yay, read it. Oh, I love that you got that. Wonderful. One of my favorite books. People like Einstein, who had mystical experiences. People like Nikola Tesla, who talk about their mystical or their awareness of the subtle aspects of reality. There, somebody like Shakespeare, who understood the esoteric aspect of life and conveyed those teachings through his mastery of the English language. So there is a relationship between the intellectual side of one's being and the spiritual side, which is beyond the intellect, but related to it, right? If we want to enter into a state of samadhi, the intellect is in abeyance. There's no intellect operating. But how can the intellect seize? Well, it must be orderly, clear, and one must have command of it, or it must have command of itself. The thinker and the thought are one. When the I thought goes away, there is no thinker, there's no self. So all of this is a part of it. And mathematics offers one of the most direct means by which we can structure the intellect. Mathematics is the study of dimensionality itself, of possibility itself, of abstraction itself. Mathematics, unlike anything else, can be done. You can close your eyes and you can have a conversation with the universe and tap into the galactic encyclopedia within the Akashic. In a way, it's reading the Akashic. It's reading that which is independent of humanity, of culture, of time, of anything, and it can be perceived directly. So we're seeking to make this a spiritual practice, and that's why it's just the two of us. But I'm sure it'll grow into many, many, and really, I have no choice because this is who I am. So I'm being what I am, and I have to be that now. So Other issues are people are not investing in themselves. They're very busy and locked into whatever they think matters in life. But the most important thing is to liberate oneself. The most important thing you can do, obviously, is beautify the lens through which the world is seen, the self. Then no matter what you have, no matter who you know, is augmented into the divine perception of beauty, right? So working on the lens is very practical. It's not impractical to prioritize spirituality and the refinement of the intellect. It's highly practical. It's just a misunderstanding that the joy of things and people and circumstances is a function of things and people and circumstances. It's actually a function of the self. So this is a spiritual practice, and what I'd like to help you do, should you resonate with it and feel like you're ready for it, is to build a spiritual lifestyle that integrates your spiritual practice with the intellectual aspect and also your livelihood. One of the challenges is people who live in society who aren't in a monastery have to earn a livelihood. And earning a livelihood often is has the tendency to pull people in a corrupt direction in a way that isn't being true to themselves, whether it's subtly corrupt or overtly corrupt. But how can one be true to themselves, true to their spirituality, and earn a livelihood? And I'd like to provide that solution for myself and you and anybody who's interested to live in the world and have an integration of your spiritual practice and your livelihood and your social life. Because the social life, when you're young, sometimes you just want to be friends with anybody. But when you start to find yourself, you may love everybody, but you find connection through the synchronicity of being with somebody who loves what you love, who's doing what you're doing, who has a purpose that is in alignment with yours. And that self-transcendent relationship where we live for something greater than ourselves brings us closer together. And that's what creates the most beautiful friendships in life, and not just the friendships that are often a matter of mutual exploitation and a satiation of one's inner insufficiency. When somebody is feeling insufficient, they may reach out. But in meditation, we sit in our insufficiency until it turns into wholeness. And then we can live a different kind of life, right? So, well, thank you for listening so much into my descriptions of this. I think it's important. And I'm recording this so that I would like to share it, and I hope that's okay with you, so that people can hear what I just said and perhaps join us next time. So today I have a fun lesson.
Okay.
Let me share my screen. This is desmos.com. And your camera turned sideways. Yeah, it's back to normal. This is desmos.com. It's a graphing calculator. And here I have done a little mathematics to draw this animation for the purposes of the lesson. So let me start by turning this off. So what do we have? I'd like to contemplate rotation and angles. So here we have something rotating until it's making a complete circle. So what is how do we approach mathematics in a way that is deeper and more profound than the way it's done in school, and the way it's done by society? that is not a utility or a purely mathematical pursuit, but rather a spiritual pursuit. So we have to start considering that we live, what is dimensionality, possibility? It means that we have the duality of this or that, here or there, then or now. There's duality, there's possibility. And within that realm of possibility, there's the possibility of moving forward and backwards, up and down, left and right. You can go into the fourth dimension. You can go into all different aspects of dimensional possibility, which have the quality of movement. But then there's also the rotational aspect within dimension. If something can move, it can rotate. And it's interesting, in the fourth dimension, there are 6 ways to rotate. In the third dimension, there are only 3 ways to rotate. And in the first and the second dimension, there's only 1 way to rotate, which is the one we're going to study here. But isn't that amazing to think the fourth dimension has 6 ways to rotate? There's, where there's in the third dimension.
Yeah, that's amazing. But how can you define fourth dimension?
Well, we're going to do that in a future class.
Okay.
It's a tricky thing to, study of mathematics is not the study of physics. And people want to understand the universe and they say, whoa, galaxies, planets, things like that. We're studying the inner dimension of possibility. It's the inner dimension. It's the unmanifest. It is beyond our universe of space and time, galaxies, atoms, matter, and energy. It's beyond that. And that is why it's reflected in the lesser scope of physical manifestation. Mathematics is an open scope of all possibilities. So we can start talking about any dimension we like, whether it exists physically or not. Physical means nature. The word physical means nature, but the nature of dimensionality is a deeper nature. In a way, this is the more essential physicality, natural occurrence, right? And of course, if we don't understand the beyond, right, the source, the non-dualistic realm from which the dualistic realm arises, this also has not complete meaning either, right? Because humanity feels that the only realm is the realm of duality. And until you experience samadhi or nirvana, you don't know the realm beyond the dualistic realm. There's a realm in which there is no diversity. There's no self, and yet there's no one to meditate. There's no meditator. It's lovely. I always love it when I go there. I don't go there all the time. And I'd like to be in that perpetually, which is something called Sahaja Samadhi. And that's my goal as a spiritual seeker. And what I'd like to do as a part of this program is to perpetuate along that by sharing and doing it with friends and making a livelihood and having money for basic needs and for also to thrive, which we should all have, is so our soul and our spirit can thrive in the dualistic expression of the spirit. That's important too. So we have to make money, not by taking a piece of the pie, but by adding to the pie, right? We're going to add to the pie. We're going to make the world happier for people, right? So it's love, it's bhakti, everything all integrated. I'm so excited about it. So, okay, so let's go back to the 2-dimensional space in which there's only one rotation, which is you can rotate. We can only rotate in this way, around what you might consider the z-axis pointing out, right? We're rotating from the x-axis to the y-axis, from the up and down to the left and right. So in 3 dimensions, we have, pitch, roll, and yaw, I think it's called. And in 4 dimensions, we have 6 different ways to rotate, which is really a lot to think about. So what is rotation? How can it be quantified? In mathematics, we seek to quantify things. We seek to take this ineffable thing that's beyond words, that just is in its isness and its suchness, and we seek to quantify it. So the first question we may have is, how can we quantify rotation? How can we measure it? So we might say we have one turn versus 2 turns versus 3 turns versus 4 turns. Okay. And every child has played with the number of turns. They may roll down the hill or spin around, right? Numbers of turns. If we call this 1 turn, we may also have a half turn, where we talk about fractional turns, right? We may have a quarter turn, a third of a turn, a fifth of a turn, 10th of a turn, a 360th of a turn. Why 360th of a turn? Well, that is what I would call a human artifact. That has nothing to do with mathematics. 360 is a nice number to use in terms of fractional turns for a number of reasons. One, it has many factors. It's a factor of 2, 3, 5, 6, 8, 9, 10, 12, 15. It's a factor. It can be divided by all those numbers, which makes it very useful. In addition to that, it's quite small. So we can talk about a 1 degree turn, which is nice. We don't have to talk about a 0.000 something degrees. And also there are 360 days approximately in a year. So as historically, as an astronomer who might be applying mathematics, looked out at the cosmos, observed that the sun moves approximately 1/360th of a full turn each day, right? So that would be a reasonable number to use. But as mathematicians, we want to look beyond the 360. 100 could make sense. 144 could make sense. 12 sets of 12. I prefer the base 12 system. Personally, I think it's a great system to use, the system of dozens. 144 would be a dozen, so that might be a way to do it. We could use 400, which is actually used in some situations, nautical situations, I believe. So to recognize that there's this way of measuring turns that is fractional. That's one way, fractional turns. And the fraction with which we use is somewhat arbitrary. So we can talk about a third of a turn, quarter of a turn. This is one way to measure rotation, which is also like arc, right? Here we have a half arc, which is also a half rotation. So they go together. So there's another way. The other way, which mathematicians like very much, do you know what it is? I'm talking a lot. A lot of times when we do mathematics like this, one of the ways that makes it spiritual is to practice applying the spiritual principles that make one more conscious. Principles like silence and speaking from silence, gentleness and feeling the meek energy, which awakens power in the Kundalini. Dispassion, not being excited about something, but allowing the beauty of the universe and its fullness move through you, which can only be done in a state of dispassion. If you get excited, you kind of make it smaller. The whole grandness of the universe can't move through you when you're not in a state of equanimity. So we'll get to those as a practice later on, the principles with which we practice mathematics that change the way that change our karma, that change our life in every other aspect of our lives, every aspect of our lives. So would you like to guess what the other way is? A completely fundamentally different way to measure rotation and angles. It's not fractional. It's not some fraction of turns. Do you know what it is?
I would like to know.
Okay, wonderful. So we can look at it like this. So right here, what I'm going to do now is measure a number of radii, a number of times the distance from the center of the circle goes around the circle. So if we look at, let's say the first one, let's stop right here. This blue line is the exact length of the white line. You can see it's like the white line, the distance from the center is the distance of the arc.
Okay, you mean to say that the radius of the circle is equal to the length of the arc.
Exactly. The radius of the circle is equal to the length of the arc. And I can turn off the screen. In fact, let me turn the lines off. So if we do that, we can go around like this and see that we have one arc, one radius, two radius, three radius, four radius, five radius, six radii, and a little bit more. So these are called arcs of radii, rotations of radii. In English and today's language, we call them radians. But of course, this exists beyond today, that there is the measure of rotation that is equivalent to the rotation that produces an arc equal to the distance from the center of the circle. These are called radians, and mathematicians really like these ways to measure angles. So if I were to say, what is if I were to go to the A and type in 6, this arc from there to there is 6 radians. So 6 radians is less than a full turn. What is a full turn? Tau radians. Tau is the number of times, it's a number, it equals 6.283 and goes on forever. It's defined by this property of circles. It's not defined
Yes,
by
and
a single.
yes, and 6.28 is merely equals to 2 pi.
It is, did you say close to? It's exact, did you say close to?
Yeah, yeah,
It's exactly 2 pi. Now
yes,
it's interesting because, okay, you're probably thinking, well, Adam, why don't you use 2 pi? And the reason is, well, aren't we asking how many times it goes around the circle? Tau is the number. 2 pi is actually a different description of a circle. And while society uses 2 pi and they don't use tau, I all the way through school, I have a degree in physics. I never learned tau. I never even knew it existed. I don't know, maybe other people do, but and I taught for thousands of hours as a tutor, many different classes. I never saw tau until one day I decided that if there's a number pi, there's a number cake, because pi is like a food and cake is like a food. And cake would be the alternative value for pi. I thought of it as an alternative value for pi. If pi was defined as the distance across the circle, right? This distance all the way across goes around the circle, that's pi. Then we could also say there's another way to define pi, or this relationship between arc and radius, which would be the distance from the center of the circle going around the circle. So that is cake. And then one day I learned that actually has a name called tau. A student of mine who I worked with for many years, him and we came up with the word cake. I don't remember if it was him or me, but it was a fun time. And it's nice to recognize the human artifact in that decision. One, we're naming it. Two, we're naming it based on one of these two ways of describing it. There are other ways to describe this relationship. You could say what area of a circle, what area of a square, what fraction of a square is filled up by a circle that is inscribed in that sphere. That's another way to describe this relationship. And all the equations we know in mathematics, pi r squared equals area, circumference equals 2 pi r, will be rewritten with this new description. And we begin to recognize that as humans, we try to categorize, we try to We try to name things, but when we name things, we lose their freedom, their essence, because we've imposed upon the thing our own perspective. And we're seeking to go beyond perspective. That's the only way to apprehend truth, is to transcend the conditioned mind with its perspectives, to see with a mind that is in abeyance, to be in abeyance. A mind that's in abeyance is truly listening, not listening with the responsive thought, with the self-centered activity of agenda and interpretation, judgment and opinion, but listening with the dispassion of enlightenment. So we're seeking to practice that and apply that principle and become aware of human tendency to not live in that enlightened way by seeing that pi and tau are arbitrary choices, or their names, and two ways of perhaps, I had another way I suggested, inscribing a circle and a square, perhaps circumscribing a circle around a square, but maybe there's others even. We could come up with others. We're trying to go beyond society here. We could very easily develop proficiency and memorize some equation. That's not what matters to us as spiritual seekers, right? We want to go further than that. It's not about the results, it's about the experience. It's an autotelic practice, a practice that we do for the sake of doing it, not for the utility of it, not for with attachments to the results. Okay, so these are radians. We can use the name, but we have to recognize that the name is merely a name and a cultural agreement of a name, a pointer to something. So this is 1 radian. This is 2 radians. This is 3 radians. Notice it's a little less than half because pi is 3.14. 4 radians, 5 radians, 6 radians. And then it's kind of fun to put the numbers here. We can see the x and y coordinates. This tells us it went over by 0.54 radii and up by 0.841 radii. And each of these tells the over and up of the radii, right? We can also define this in terms of degrees, which would look like this. Lots of little tiny rotations. These are degrees. Right, you see, so a degree is a very small distance, right? But a radian is actually much bigger than a degree. And I would encourage you to ask how many degrees is in 1 radian. Let's make this a little homework assignment, a contemplation practice for you. Go into silence, into meditation. This is not your meditation. Meditation is a formal practice of looking beyond and looking to the center of existence, the essence. But in the mindfulness practice of mathematics, we are going into silence and gentleness and contemplating something until we see it. There's no rush. Sometimes I take a whole hour and I have a very deep insight meditating on mathematics with my eyes closed. I do mathematics oftentimes with my eyes closed, and I go into mystical states where there's actually light washing through me. You can see Shakti. Shakti is an energy that exists beyond the astral plane of Kundalini chakras, astral tubes, in the plane of the mind, the plane of consciousness. It's made up of a brightness that you can see. It's divine. It's divine light. It's very sacred. And when you go into a beautiful state of freedom and detachment and love, the light happens. And if you do mathematics from there, that is the part of the mindfulness aspect of our practice, to learn to do that. It took me many years to be able to do that. I hope to shorten the time for people I'm working with. I'd love to help you do that quicker. Maybe you do it already. I'm sure there's maybe some people in the world who do that. Maybe. So certainly go into light, but I'm not sure how many people go into light and do mathematics from there. So practice that. How many degrees is equivalent to 1 radian? And another question is, what fraction of a turn in the base 10 system, how many percent of a turn is 1 radian? So these are a couple questions you can ask. And perhaps write those down. That's the homework. I'll write it down. Okay. Okay, the next thing is, it's fun to maybe just look and see what happens. The difference between radians and degrees is there's no integer number of radians that goes into a circle. 360 degrees goes into a circle, but how radians goes into a circle, into 1 full rotation. And we can see this when we draw these lines here. You'll see that we get this pattern, which comes from the fact that there are not an integer number of radians in a circle. See, the second time around, you could say 720 degrees, and that will land right in the same spot as it did in the previous circle. It'll coincide with a previous spot. But here, every time we go around, we're finding different amounts. All right. So now it's not enough to just see, that's 47 radians and ends up right there. 47 radians is touching this one. It's not touching, and oh, notice it's not on a degree. Here's the closest degree to it, right? So these are radians. We have radians and degrees, and we're contemplating angles and rotation. So this is a quick lesson. It's really, you can contemplate this for many years. Can you tell I've really thought about this? I've been studying this for 35 years. Right, so it's good to go, one of the practices in spiritual mathematics is to stay with the basics. You can learn about the number 1, something you never knew. Because you can learn about looking at a tree, something you never knew. Can you look like Ramana Maharshi looked at a tree? Like Krishnamurti looked at a tree? Can you look and see it? How well can you do that? Can you do that with the number 1? Can you do that with angles? Can you, we're seeking to go beyond this exoteric knowledge to the esoteric knowledge. We're going to something deeper, something subjective. We're moving into the subjective space of mathematics, not simply the objectiveness of it. Right and wrong, sure, it's right and wrong. But to what degree do you bring that right and wrong into your own being? Well, that is a dimension of continuity and multidimensional potential, right? Okay. Notice I said multidimensional potential. You see, I'm looking at when you master something, when you study something, it can become a lens through which you make sense of the world. Mathematics offers a very powerful way of making sense of non-mathematical things, seemingly non-mathematical things, right? Think about the subjective space is multidimensional, right? You see, multidimensional means it's got all these different quantifiable qualities, right? It's a mathematical metaphor that can empower one's ability to understand much of life and different aspects of life, subjectivity, for example, versus objectivity. All right, let's move into something a little bit more interesting and advanced. This is a little more, this you can become advanced in the basics, but let's look at something a little bit more advanced in terms of its complexity mathematically. Now, I haven't created an animation for this, but if this was a radian, what is there perhaps a three-dimensional version of a radian? And what would it be? What would a three-dimensional version of a radian be, right? So, so it would have to do with a sphere instead of a circle, right? I like it. You're feeling the sphere. It would have to do with a sphere instead of a circle. It would have to do with the radius. So if we were to perhaps imagine a sphere, this is now a sphere, and on this sphere, we have a radius sticking out, right? And what if, radian is a measure of arc. Well, what would a three-dimensional version or a two-dimensional surface? It would be not a line, right? An arc, it would be a surface. So imagine there's a surface around this. It's kind of like domed a little bit, right? It's a surface. And what if this surface has an area of 1? Right? If this has a length of 1, then this has an area of 1. Now, a length of 1 and an area of 1 are actually two different kinds of 1, right? A length of 1 is this. An area of 1 is this by this, which produces a 1 by 1 unit. So in other words, we're saying, okay, what if we were to kind of take this length, turn it into a square, and then reform it into a circle on the surface of the sphere, right? So that's the relationship with 1. People think of 1 as 1, 2, 3. It's a number. Well, it's a little different, right? We're talking about a unit 1 in the two-dimensional space here, right? So it's the 1 that comes from taking this arc length of 1 and doing an arc length by an arc length that makes a square, and then reforming that square into a circle that has an area equivalent to the square. And then putting that over here and calling that a two-dimensional radian, a square radian. And it's actually called a steradian, from a Greek word, S-T-E, radian, steradian. Interesting concept, right? You rarely hear about this. This sort of thing can be used to tell like how wide a laser beam is. It could tell you perhaps something about the size of Jupiter, right? How many steradians does Jupiter take in comparison to, like, for example, if this was the sun and this is Jupiter at a certain distance, right? How many steradians does Jupiter span at that distance, right? You see, you can start looking at the universe this way. Yeah, I guess you could say how many radians does it do, but Jupiter appears as a sphere in the sky, right? Here's Earth looking at Jupiter. How many steradians is that? It'll be different, right? Because we're at a different distance from Jupiter. If you look at Venus, Venus has phases. I don't know if most people, I don't think, realize this, but if you look at Venus with a telescope, you'll see that it has phases like the moon. And those phases are accompanied by a change in size as well. So when Venus is close, it looks bigger and it has a phase. And when it's further, it looks smaller with a different phase. You see, so we can start looking at the universe in this way. Like, how many steradians is that? If it was, what would the area of one around? It's obviously a fraction, very, very tiny. But primarily, we like to stay centered in the math and look out at physics, astronomy, other art, other concepts like that. But really, it's about the math. So next question is, if there are tau radians in a rotation, how many steradians are there in a sphere? Good question, right? So I
That's
can,
a question to think.
yeah. So, well, if you knew the surface area of a sphere, right? We know the circumference of a circle, or how many times the radius goes around the circle, right? That's tau, right? Now, in a way, we don't know, right? Because tau is really just a question and an answer. It's also a question, right? That's tau. What's the number? 6.28. 6.28 what? 6.28 something else. Okay, well, here's a billion digits. Well, I still don't know what tau is. You see what I mean? You don't know what tau, we don't know what tau is. Tau goes, there's an infinite number of digits that we'd have to include to find a precise tau, which is obviously, the tau is tau. Tau is tau. It's a question and an answer. You see, we want to bring the question and the answer together and converge into one, right? That's a powerful thing to do, right? So tau is a question and an answer. So perhaps there's a new tau. Like, I've never done this before. Let's call it a tau 2. Oh, love it. Yes. Okay. This is a tau 2. It will represent the spherical analogy to tau. This is just coming right now, and there may even be a number for this, but what would tau 2 be? So, well,
Okay, so tau 1 is related to circle and tau 2 is related to sphere.
right, it's how many radians go into a full rotational arc, tau.
Okay,
How
so
many
yeah, so
steradians
we need to find the relationship between tau 2 and tau 1.
Well, listen to this. How many radians? So tau 2 is how many steradians cover the surface of a sphere.
Yes.
So, well, we know that the area of this is 1. So if we knew the area of the surface of the sphere, we could find it. What is the area of the surface of a sphere? Now, this is a whole separate class. So in order to do this within the next 5 minutes before the class is over, I'm going to have to tell you that what's the area of a circle even? So this is a whole other class as well. So we're making a few jumps here. We'll get to this another time. It's pi r squared, or tau over 2 r squared. That's the area of a circle. And it just so happens that the area of a sphere is exactly 4 times that, which is very strange. And it's a beautiful thing, and you can see it actually intuitively through the direct perception of mathematical truth, which is what we're trying to do here. But we'll go with that. So the area of a sphere is 4 times pi r squared, or 4 times tau over 2 r squared, which equals 2 tau r squared. That's the area, surface area of a sphere. So the question is, how many times does that area of 1, now in the case of the sphere, it's called a unit sphere, right? Because this is 1. So r equals 1. So what does this could become? 2 tau r squared becomes 2 tau 1 squared. And squared means 1 times 1. So 2 tau times 1, 2 times tau times 1 times 1, which equals 2 tau. So 2 tau is the area of a sphere. And we want to know how many of these areas go into that. Well, if this is 1, we've actually defined it already. It's 2 tau, which is 12.57, I think, about that. 12.57. So 12.57 areas of that will go on to that. I think I'm correct. I hope I'm correct. It's also the same thing as for pi. Now tau 2 then would be, so tau 1 is a number, is it just literally 2 times it? Literally just 2 times it. I believe that's right. I'll have to double check with Wikipedia later on. So tau 2 is just 2 tau. And of course, we can do this in the 4th dimension, which would be very tricky, because in the 4th dimension, the hypersphere, the 4th dimensional sphere, is encapsulated not by surface, but by volume. Its shell is a volumetric shell, a voluminous shell, right? Because you see here, we're encapsulating volume by area. In a circle, we encapsulate area by a line. In 4th dimension, we encapsulate hypervolume by volume. So we would say our surface would be a unit sphere volume. And we'd have to ask, how many times does that go around that hypervolume? So then what are we going to say tau is? Tau is the number of times the radius goes, tau 1 is the number of times the radius goes around the circle, and tau 2 is the number of times the unit radius area goes around, covers the sphere. And we're getting, it's 2 tau. So tau 1 equals tau 1, or tau 2 equals to tau 1. Wonderful lesson. Let me do that tau right. Okay. This is wonderful. Ayush, thank you for listening and bringing your energy. It wouldn't have been the same without you. I would have.
Thank you so much for bringing the whole new, different perspective of showing the mathematics to me. Like from the classes, from the schooling, I just knew that it is pi radians or like all about degrees and all. But you have shown me a new, different way to, introspect the things, introspect the mathematics. So it is really new and exciting things to me to look this same thing from a different perspective.
I love it. Yeah, it's really wonderful for people who've studied math who are like, wait a second. You know, when I teach a 13-year-old, they don't even know that I'm teaching them something different.
Yes,
they're
yes.
just take it for granted. But when I teach a college student, are you an engineer? You're studying engineering?
Yes. I am a chemical engineer.
Wonderful, wonderful. Well, hopefully this will also bring some really beautiful abilities to your chemical engineering, right? When you really understand these things, it makes it all so much easier. So I commend your interest and sincerity in taking your mathematical abilities beyond what they ask of you, right? And your interest in just doing it for spiritual reasons. But it's the spiritual practice, when we take mathematics all the way, we enter into heightened states of awareness, right? It's like mastery of anything can do that, actually. So if you want to master dance or art or chemical engineering or whatever, martial arts, Bruce Lee is a perfect example of somebody who did this. He took martial arts so far into liberation. Like he took it so far, and that's why he stood out so completely as somebody who was doing it in a fundamentally different way, which is similar to what we're doing here. which is formless form, to meet the moment, not through our conditioned techniques, but through a response that is a response that is unlimited, that is free to attend to what is. You know, in martial arts, if you just do the same punch every time, it will never meet the moment optimally. But if you look at the moment and allow the intelligence of the universe to punch in exactly the right way, with exactly the right opponent, in the exactly right position, with exactly the right amount of energy that you have left, you know, you're accounting for all these things. And that's a movement of love, even in martial arts, ironically. So in mathematics, we're seeking to approach math in that way, with formless form. It's a Taoist concept. And of course, it applies in yoga and Buddhism and everywhere else too. But so I'm gonna share this Desmos with you right now, so you can play around with it. I'm gonna send you the link. I'm gonna record this. I'll send you a link so you can review it. And tomorrow we have pure meditation and energy work. If you want to come at 6 o'clock, we'll have just a meditation group. We'll be going over the chakras, talking about actually the topic is building a routine and how important that is for awakening greater consciousness. So. And let's take a 1 minute meditation. Yeah. Did you want to say something?
Yeah, sure.
All right, 1 minute meditation. Let me stop for a moment. Let's play the music. And once we've developed all this structure, focus on mathematics beyond the human aura, it's quite wonderful to step back and revel in its structure and lucidity, and the energy and power we've cultivated in this hour. We'll do a 4 minute meditation. That's how long this song is. That's okay? Is that okay? Yeah. Namaste, Ayush. Thank you for a wonderful time. I'll see you soon.
Thank you. Thank you so much. I'm feeling so blessed, so happy that I've joined this meeting and to have you. Thank you so much.
You're
I'm
welcome.
so grateful.
I am so grateful for you. This is wonderful. Really nice to meet somebody who is resonant with what I love. So, yay. Woo. All right, I'll see you next time.
Sure,
Bye.
sure, sure.